This is Henry Grossman back with the exciting conclusion of parametric glass for parametric design fall of '09. When we last left off, we had an axis and we had a profile curve, and we were just about to get to the fun part. We're going to make a surface. So here under surface, I want to create a revolution. So revolution, a revolved surface, takes a profile curve, a revolution axis, and an interval. And in this case, the interval goes from 0 to 2 times pi, which is a full 360 degrees in radians. And we had just taken our list of points, brought it to this interpolate curve. What we should have done is made a parameter. Can turn off the preview here and call this profile curve. And we can take that profile curve into the revolved surface. And we have our axis, that was the first thing we made, over here. So there we get our surface. So now we have a nice parametrically controlled surface. Right. So let's do two things. One, let's say we wanted this profile curve to have 4 points, right? That would be pretty easy at this point because we made this cluster that takes a point and moves it in a standard way. So we could highlight it, copy, Control Z, paste, Control V. Take point 3 as the new input. And we can make a point 4. And then here we had a merge 3. And we could just get a merge 4. There's point 4, point 3, point 2, point 1, and we could use that as the new point list. And there we go. Now the other problem that we have, what's nice about the way we've set this up is we have a parameter for our base radius. So if we knew that we wanted, no matter what, that base radius to be 4 inches, we could just set it. I guess this is more of a parametric bowl. It's quite large. But we've got a hole in the bottom. So let's create a one more surface. First, let's create a curve. Let's create a circle for that bottom. So if I go here to curve, I can create a circle based on a normal and a radius. So the center point of that circle is our origin point, right? It's that point right there. The normal, that's a vector that points to in the up direction. And you can see here in the front view that the up direction is Z. And the radius, as you can see, is by default it's 1 if I hover over it. But we know what the radius is. It's this parameter that we set with our slider. Oops. So we can hook that up. And now if I highlight this, you see I have a circle. That's my little base there. Let's make it bigger. If I double click, how big could that be? 25. Let's make it 15. There we go. So now we have a parametric fruit bowl or something. Now the reason why I wanted to create this circle is because another way of making a surface is just to take a curve or a collection of curves, but in this case one closed edge, planar edge curve will do it. And we can use that to make a surface. So now we have, it's a kind of primitive bowl, but it's a bowl. And it's made out of these two surfaces, a revolved surface and a planar surface. And I can do the same thing that I did before. I can turn these into a list of surfaces with a merge, if I turn off the preview. And then I can create a surface parameter. And the reason why I'm doing this is because what I want to do is I want to bake the geometry. And what baking geometry does is it takes grasshopper, movable, flexible, parameterized geometry, and it makes it fixed rhino geometry. So if I select surface, and then I don't know why bake is a fried egg, but it is. If I click on that, it takes my parametric object and it makes it a no longer parametric object, but it makes it a rhino object. And I can select it and I can move it. I can move it over here. And now when I go back and I change it, if I decide that I want something a little bit more, I don't know, a little bit more squat, and a little bit more slender, I can now go back and select that. See, that's a list of two surfaces, so it's selecting both, and I can bake it. I can move these over. And I can change it again. And in this way, very quickly, actually, here's an interesting idea. What happens if I take this and I'm going to change my slider so that it could be negative? There we go. So very quickly now I have three objects, which are real, renderable rhino geometry, that are all one part of one parametric family. There's a continuous difference. There's things that are the same and things that are different. They're a parametric family of, well, they were supposed to be glasses, but they turned out to be bowls. C'est la vie.